Hello and welcome to the NXP booth at the Intel Developers Forum, IDF 2014, here in San Francisco, California. We're going to show you a demonstration of new technology that can be applied to the Internet of Things. Not familiar with NXP? Let me explain. NXP is a semiconductor company that makes circuits or chips that are used just about everywhere in many applications throughout the world. We're going to focus on one type of technology and one family of chips called the NXP I2C bus. Not familiar with it? Let me explain. From humble beginnings in television remote controls and early microprocessor interfaces, the NXP I2C bus is ready to take on a new challenge. The NXP I2C bus works efficiently and quietly behind the scenes in both large-scale applications, such as computing, industrial, storage, and the amusement markets, and also in emerging technology, the Internet of Things. Not familiar with the Internet of Things? It's the next frontier in the interconnection of uniquely identifiable embedded computer-like devices within the existing Internet infrastructure. There's no limit to what or how many things may be connected, or what they detect, report, and control. Machines will connect with other machines, much like humans connect with other humans today. How big is this Internet of Things market? According to Gartner, there will be nearly 26 billion devices on the Internet of Things by the year 2020. Stop and think about that for a moment. There's roughly 7 billion people on the planet today. 2.5 billion of them already have smartphones. These are interconnected by broadband communications, cellular infrastructure, and the Internet. Why not reuse that technology alongside those phones for other devices to talk to each other? Hence the Internet of Things. So why is the Internet of Things important to NXP? The Internet of Things has fingers with embedded sensors. The heat, light, touch, sound, and vision, position, and near-field communications, to name a few. Data and control of those sensors requires an interface. Currently, the most popular interface is the NXP I2C bus. You may also have heard of SPI, another technology we have. In addition, we have voltage level translators that are used to operate with very low voltage supply microcontrollers and specialized chips. Internet of Things devices are connected together using broadband internet. Data from these Internet of Things devices is retained as needed in cloud storage. For our demonstration today, we have all of those pieces assembled together. Using cellular handsets with additional hardware from NXP, we collect temperature readings periodically from an NXP temperature sensor. We process that data using a microcontroller. The two devices are connected together by the NXP I2C bus. Using the cellular handset and a countdown timer, we transmit that temperature data along with the location GPS coordinates of the phone up to the cloud. From there, a web browser right in front of you here in the booth displays a map and the latest data. This is a very simple Internet of Things, and it's made possible by temperature sensors and the Internet of Things hardware that we showed before you. The hardware itself from NXP is called the Quick Jack. It plugs into the audio connector of a phone, smartphone. It could be an iOS or an Android type of system. It uses such little power, it can be powered by the audio channel in the phone itself. One channel is used for power, powers the board. The other channel is used as a modem to take that data from the external hardware into the phone and later to be sent over the broadband connection. You may think of the I2C bus as the everything bus. There are currently over a dozen different sensor technologies that interconnect with each other and with microcontrollers using the I2C bus protocol and the I2C hardware. Both are developed and maintained by NXP. I hope you enjoy your visit to IDF. Enjoy the